A vector field is considered to be conservative if there is some sort of a scalar function such that the gradient of that scalar function is equal to that vector field. The scalar function whose gradient is that vector field is called the potential function of the vector field. And so for any scalar surface function, the gradient of that surface function is going to be a vector field. And because that vector field came from this scalar function, we say it's a conservative vector field. And that seed function is called the potential. So let's take a look at a scalar function, f at x, y. This is some sort of a surface. Del f is calculated by looking at first partial with respect to x, first partial with respect to y. The first partial of the surface with respect to x is just going to be 6x. The first partial with respect to y is just going to be 2. So our gradient vector field is 6x and 2. And again, this is going to have an output that's a vector, which depends on the domain element we plug into it. And here's an image of a portion of this gradient field. So if we were given that vector field to begin with and we were asked to find the potential function is the surface function whose gradient is the vector field.